Okay, so today we're going to be working on worksheet 4. Our success criteria that we're thinking about here is that I can explain the law of definite proportions. You had two different laws we talked about yesterday in the notes. One of them is law of definite proportions. The other one was law of multiple proportions. I told you the best way to keep them separate in your head is to remember that definite proportions, the one that's important to us, is just talking about a single compound, what it's made of. It's always going to be made up of the same ratios of atoms, and therefore the same mass ratio. And this should help drive home the point today on this worksheet. So I'm going to do 1 and 2 for you, and then I'm going to let you guys get to work the rest of the hour and have this done for tomorrow. So number 1, table sugar is a compound known as sucrose. Sucrose is composed of the elements carbon, hydrogen, and oxygen. Analysis of 20 grams of sucrose from a bag of sugar finds that the sugar is composed of 8.44 grams of carbon, 1.30 grams of hydrogen, and 10.26 grams of oxygen. 1A, express as fractions the ratio of the mass of each element to the total mass of the sample. What is the total mass of the sample? Okay, so yeah, it says it's 20 grams of sucrose. So that would be our total right there, 20 grams. So you guys may want to use a separate piece of paper for this, so you're not writing this all crowded like how I am. So for each element, so I'm going to start with carbon, whose symbol is C. So I'm going to take the amount of carbon there is, 8.44 grams, and I'm going to put that over the total amount, which again is 20.0 grams. All right. Hydrogen's next, so I'll put H. H equals 1.30, so I'm going to put 1.30 over 20.0. And then O, oxygen, says there are 10.26 grams. So out of that 20 grams, 10.26 grams is oxygen. All right, so there's our fractions. It says using these ratios, calculate the percent composition by mass of each element in the compound. So this is what we were working on yesterday. We were talking about percentages, right? So on the percentages, what I'm going to do is for carbon, I'm just going to do that fraction there. I'm just going to divide it, and it's probably going to give me a decimal that I will then multiply by 100%. So just to start off, if I take 8.44 and divide by 20, I get 0.42. And when I multiply that by 100%, all we got to do is move the decimal 2 to the right. That makes it 42% carbon. So that sucrose is 42% carbon. All right, do the same thing for hydrogen. I'm going to take 1.30 and divide by 20, and I'm going to get 0.065. So again, multiply that by 100%, move the decimal 2 to the right, so it's 6.5% hydrogen. And then oxygen, 10.26 divided by 20 comes out to be 0.513. Move the decimal 2 to the right, and I get 51.3%. Okay. All right, number 2, a similar chemical analysis is performed on a 500-gram sample of the sugar isolated from a sample of pure sugarcane. Analysis shows this sample contains 211 grams of carbon, 32.5 grams of hydrogen, and 256.5 grams of oxygen. So the total amount of the sample is 500 grams, okay? Determine the percent composition by mass of each element in the sugarcane sample. So the first one I'm going to do as I go through this sentence here, 211 grams of carbon. So I'm going to do carbon. It's going to be 211.0 over 500. So if I do 211 divided by 500, I get 0.422. Multiply that by 100%, and it says it's 42.2% carbon. All right. All right, we're going to go to hydrogen. And it's 32.5 grams divided by 500. Which comes out to be 0.065. Again, move the decimal 2 to the right. And I get 6.5%. And the last one is oxygen. And it says the oxygen is 256.5 grams. Divide that by the total, 500. And it's 0.513. So that would be 51.3%. So B, could the sugar in this sample be sucrose? What do you think? So from the sugar cane, could this be sucrose? Why is a total 20 on number one? Because so this sucrose is the whole thing. So when they say analysis of a 20 gram, it should say 20 grams of sucrose. So that's the whole thing. And then they're breaking it down. Sucrose is made up of this, and oxygen. Okay, so all together they should make 20. That'd be the total. All right, so 2B. Answer should be yes. Why? It should be 100 or close to it, depending on how we round. So the percentages are the same or similar, very close to the being the exact same. So this is our law of definite proportions, right? No matter how much we have, sucrose is always going to contain carbon, hydrogen, and oxygen in the same amounts, the way they combine with one another. Okay? That is the law of definite proportions. So I'm going to let you guys try the rest. Working on this worksheet today, I just wanted to get you started. So here we go.